Hello everyone, welcome to Fahad's tutorial. In this lecture, I shall be explaining the deduction of the third equation of motion, which is S equal to ut plus half a of t squared. So, this equation actually a very important equation and we need to use it a lot of times in case of mathematical calculations. So, how it derives? In case of explaining these things, we need to think that a body or a moving car is starting with an initial velocity which is u, and through a uniform acceleration it comes here and achieve the initial velocity over time, and in this time period it crosses this displacement. So from here to here, it definitely crosses the distance, and as it is a vector quantity, this should be the displacement. So here we have 5 different quantities, which is uniform velocity, final velocity, acceleration, time, and the displacement. So if this is the scenario, we must know that in this case we have an average velocity. That means average velocity means that we said it's uniform velocity. So in case of understanding the velocity, we must know that this is actually an average velocity which is equal to displacement over time. Okay, so as it's moving from here to here, there will be an average velocity which is like this, and through this equation we will find that S is equal to var V into T. Suppose I wrote it as the equation number 1. And we know from the average velocity, if you see my previous classes, I will explain already that what is the velocity, average velocity, acceleration, average acceleration, displacement. So in English medium classes on lecture 3 in unit 1, I already explained these. And this is the average velocity. So from the equation of average velocity, we can say that this V is equal to V plus U over 2, because this is a very simple average of 2 velocity over 2. So we'll find this is initial velocity and this is the final velocity. If we add it and then divided by 2, we will find the average one. So if we add this value here, we will find that S is like this. So I will write this equation over here. It will be V plus U by 2 into T. So this is actually this one. So this is actually this one. And now if we need to know that in third equation what is absent, we see that in the third equation there is no final velocity. So as we know that we have the first equation, this one, V equal to U plus AT. So on that equation, if we write that this S is, if we change V through this one, U plus AT, so we can write this U plus AT plus U 2 into T. And then what we'll find that S is equal to, here is U and U. If we add it, this will be 2U and plus AT over 2 into T. So if we add, we'll find this S is equal to 2UT plus AT and T times square over 2, and if we just wrote it, that S is equal to 2UT by 2 plus AT square by 2. Then we will find the same thing, that we can cross over, and then we'll find this one, that S is equal to UT, this UT over AT square, and this is half. So you can write it like this, half of AT square. And this is the third equation. So we have only 3 steps to follow it. That number 1. So if let a body move with the initial velocity to the final velocity with an uniform acceleration over time of period, and then in the meantime if it crosses S, then this average velocity would be the displacement over time. And this displacement is equal to, I just multiply it through the process. It's a very simple mathematics, and this is the average velocity through the definition, and I just add this amount of value here and I find it. And most importantly, in special cases, if a moving car starts from rest, then this u would be 0. So in special cases, if it starts from rest, we can say that this is 0. So S is equal to half of a t square. And similarly, like before, if we say that this is uniform velocity, as because throughout the uniform velocity, so we have the average velocity. So if it is uniform velocity, so it must be constant throughout the time. So if acceleration is constant and also half is a number, so it's also constant value. So both constant will create an equation or relation in between the displacement and time. So we can write, if this half times a is together a constant, we can write it as E is proportional to t square. And we find another relation. What? If a moving body is moving from one side to another, and if it starts with a initial velocity u and ends with a final velocity, that is v. So if u is 0 and there is a uniform acceleration where acceleration is constant, we will find a relation that displacement depends on the square of time. So when time increases, the displacement increases. So the value of time increases, it's definitely proportional to S. So actually this relationship means that this displacement is depending upon time. So it's depending on time. When time increases, displacement increase. So this is completely an independent variable, and this is dependent variable, because when I write that S is proportional to t square, I cannot write over t square is proportional to S. This is completely a different thing. So when I write that S is proportional to t square, it means that displacement is depending on time. When time increases, displacement increase. If it starts from rest and it has a uniform acceleration. So we got a new relation. We got a relation that the S is proportional to t square. And the next class, I will definitely explain about the fourth one, the deduction of v square equal to u square plus 2s. So stick with us and do let me know what is your demand. Thank you so very much. Bye.